Okay, today we're in section 2.1, comparing, ordering, and rounding decimals. All right, so the first thing you need to know that's very important is your place values, okay? If you don't know your place values, especially when it comes to rounding, there's just no way you can come up with the answer. Now, you don't have to write this down. It's in your textbooks on page 52. So, guys, just refresh your memories about this, okay? So, our decimal point is what you can call like our starting point. This is home base, okay? This is our starting point. And any number to the left of the decimal is what we call a whole number, all right? These are whole numbers, and the farther left we go, the bigger their value, okay? So I don't look at the 4 and say, oh, well, 4 is bigger than 1, so 4 is bigger. That's not how it works. We, for each place that we increase by, it counts as 10 units of the one before it. So 10 ones makes how many tens? 110. 10 tens makes how many hundreds? 100. How many hundreds make 1,000? I'll give you one guess, 10. How many thousands make 10,000? 10, and it keeps going, keeps going, keeps going. So we call it our base 10 scale. And the same goes for our decimal numbers, except now the farther right I go, the smaller the value. Okay, so again, I'm not going by which number is bigger. The farther right I go, the smaller the value. So let's say them together. My first decimal place is the tenths place, then the hundredths, then the thousands and 10,000s place. All right, we're not going to really work much farther out than that. All right, so it's important, guys, that you understand place value and our base 10 scale that we are moving by from one place value to another. All right, so how does it look in an example? Okay, you're going to be comparing decimals. This is your first section on your homework assignment tonight as well. All right, determine whose time is faster. Compare 22 and 5/10 to 22 and 12/100. So while we're looking at this, I want to talk for a minute about how we properly say these numbers. It's not 22.5, okay? It's not 22.5. We read it in terms of what place value the last number is in the decimal. Okay, so here, what place value is the 5 in? 10. It's in the tenths. So I would say this number, I'd say 22 and 5/10. Okay, now on this one, what's the place value of the last number? The hundredths. Okay, so now I read the number 22 and 12, and then I call it the place value that's last, and that's hundredths. 22 and 12/100. Okay? What if I had one more number? Now how would I call that number? 22 and 125 thousandths. Okay? So that's how we properly read these numbers. Now, when I'm comparing them to see which one is bigger, I always start with the largest place value, which in this case is the tens. But my numbers are the same. So what happens? What do I need to do? I need to now go to the next place value down. My ones, but guess what? My ones are the same too. So now I go to the tenths place. Are my tenths values the same? No, and which one is bigger? Which one's bigger, guys? The 5. So 22 and 5/10 is larger than 22 and 12/100. Now, another way that you may have learned before is to look at which number has the most decimal places and to fill in the zeros to make those numbers even. Does that ring a bell? Mm-hmm. Okay. So because I have 2 decimal places in my second number, I'm just going to add in a 0. And now I can clearly see that 50 is bigger than 12. So again, it's greater than. Okay, so either way you want to do it is fine, as long as you get the right answer. Any questions so far? All right, now let's look at example 2. In example 2, we're ordering these decimals, but again, I want to make sure that each decimal has the same number of decimal places, so it's just easier for me to compare. So which one of these numbers does not have the same decimal place? The same number of decimals. Which number? What is it? 2. Okay, so what can I write instead of 2 to make it the same number? I can write it 2.00 or 2 and 0 hundredths. All right, so go ahead and write these numbers down. Okay, so now we're going to put them in order. Which number is the smallest? 2.00. Very good. 2 and 0 hundredths, and then what? 2.06. Nope, say it correct. 2 and 6 hundredths. Now what?
2 and 11.
Come on, guys, everybody together. 2 and 11 hundredths, then what?
2 and 21.
Good, and last?
2 and 24.
All right, good job. So least to greatest, ordering them least to greatest. Any questions? Any questions? Okay, moving on to example 3 now. In example 3, we're rounding a decimal. So here's where knowing place value is so important. Okay, if I'm rounding to the nearest 10th place, what place value do I look at to know how to round my 10th number? I need to look at the hundredths place, the place that is right after the place value that I'm rounding to. Okay, and there's a little saying that goes 4 or less and let it rest. 5 or more, raise the score. Okay, which means just raise that number 1 digit. So since there's a 2 in the hundredths place, what happens to my 1? It just stays as 1. 7 and 1/10, right? That's how we say it. So now if I'm rounding to the nearest hundredth and the next number, which place value do I need to look at? The thousandths place. Very good. And I have a 7 in the thousandths place, so what happens to my 4? Changes to a 5. I raise it to a 5. And last but not least, rounding to the nearest whole number. How would I round to a whole number? What place value is that? What place value is that if I'm rounding to the nearest whole number? What do you think, Mackenzie?
10.
Not to the 10th. Oh, you look at the 10th. Very good. You use the 10th place to round to the nearest whole number. So what would it be? 11. Very good. 11. All right, very good. Any questions about rounding decimals? Any questions about rounding decimals? All right, if you understand that, that's everything you need to know for 2.1.